because you're all electrical, computer engineers, where so much excitement and revolution is taking place nonstop. And my journey followed it in these areas, in these technologies. So come and share that with all of you. What I've gone through should be able to give you an example, motivation, inspiration to build your own careers. Life is a long journey, and how you decide your values and your passion is what it's all about in your life. Yeah, there are times when you have to make a paycheck, you have to earn money. Those challenges are there, and we have to solve that. And the other thing is that entrepreneurship, we are all entrepreneurs. We all have to solve problems. We all have to take challenges in our life. So you can be entrepreneur at any age. In spite of Steve Jobs and in spite of Elon Musk and others, Bill Gates, who inspired me as well. If you really look at the entrepreneurial statistics, the success of being an entrepreneur is always 45, 50 onwards. And we also miss out a very important fact that these young entrepreneurs did not make it behind the scene, were very, very experienced people supporting them and guiding them as well. So it takes a team to work out the entrepreneurship, and I hope that I can pass on some inspiration to you as well. And then how you become an entrepreneur, it doesn't have to be age 20 or 30 or 40. You can try, and then eventually potential is always there. So with that in mind, firstly I want to make sure I thank you all very much, especially Professor Devinder Kaur for inviting me. And in intermittent, because I'm in Cleveland, we have had a relationship with the University of Toledo on numerous projects with electrical computer. It's just last 5-10 years, haven't had the opportunity to interact as much here. But the other part I want to share with you is very quickly with Professor Devinder Kaur being here, the role of women in our field. I'm going to talk about it right away, move on. And that's very important in our company, why I bring it up. And even in a developing country who has just become independent and was establishing world-class universities and inviting professors from UK and USA and what got us inspired to come here, there were 10 women in my class out of 30 privileged education for 4 years. What really helped us to make a career in the United States. And the part I want to share with you is that I was gold medalist in my undergraduate 3 years, and then a master degree, Devinder Kaur gave me the hardest time. And she won. She became, at the end, she won her gold medal, but we were in competition, and that competition was very inspiring. And so for me, it's a real privilege, as large the word is, that I get the opportunity to see you after so many years, and we kept our inspiration going since those days. Just the love of learning and love of science, physics, engineering, was always very inspiring. So with that in mind, I can start the presentation here. It's really about you, not about me. I really came that all the young faces I see here, what can I depart to you? So in order to do that, the approach I've taken is that where does the motivation really comes from when you're studying electrical, computer, all these advanced areas. In my case, it was simply that when I came to the United States at age 18, 19, the communications were so poor with my family, very depressing. Letters took weeks and weeks, and the simple text through the wire system they had, few words, was so expensive. Connecting a phone call to in the Himalayas, where I grew up in a town there, took 8 connections worldwide to make a phone call. So this is the telecommunication, what inspired me, that the passion I developed was that how can I enable global communication, and it never went away. I found every way I can really influence that. And standing in front of you today, I feel having achieved that, having contributed that to that process, and I'd like to share that with you today. So I've been a serial entrepreneur, and I'll show you why I've been a serial entrepreneur to become an entrepreneur. And that is something you can take it away from me today, that how can you be entrepreneur first, where you will get your first job, and what does that require? And then the making of the global satellite communication industry, I really want to cover with you that. The reason is that when I started, I learned about the United States, how it moves the technologies worldwide. They were world class in my days, and other countries were just coming around. And the secret was public-private partnership. Public-private partnership. And the satellite industry grew with respect to that. In my days, there was only 2 companies in satellite communication, and just the global TV, and only with the prime ministers and others, communications were just emerging worldwide, with 2 companies established by President Kennedy from Washington, D.C. He's really the doer of this, along with the space he did going back to moon. Then the making of, I don't know if there's a, beautiful. The making of the global satellite communication industry, everything you will see here and way more is what you're learning and what your professors are teaching you. And that's what all comes together and why I'm very passionate about this field. And then AI is moving in, we'll talk about that too. So transitioning to an entrepreneur, I'll discuss about what we're doing in Cleveland, Ohio, and the challenges there. Okay, so my time as an entrepreneur. First takeaway, never ever I held a job anywhere where there was any prior precedent. In management, scientists, technical, you name it. I created all my jobs as an entrepreneur within those organizations. And I was passionate to take new challenges, and many times at NASA, my manager will say, you want to turn sand into gold, you go to Cool Basin. So that's what entrepreneur does and goes after that. So you can be entrepreneur within large company as well. You just have to find the way where it's happening, and then define your journey after that. So it's pretty much like, as an analogy, it's like, water skiing, and with the waves, you're constantly going up and down, but you also have to look out. I'll share you my lesson with that. So from Purdue, my foundation took place in electronics at Gould Corporation, Purdue, in the semiconductors, what I came to study, and then along with my PhD in microwave, microelectronics area, packaging. And then I went to NASA in gallium arsenide, MMICs. I did all these areas from start out at NASA Glenn Research Center and built those areas. And then I moved into satellites, into systems, from components, subsystem to system. Part of the reason Intel is coming, big jobs in Ohio. I wish it happened when I was here. We couldn't get Professor Vikram Kapoor, he was the president at University of Toledo, tried so hard for decades to get microelectronics to Ohio. It was a very tough journey. And so, but now Intel is coming big time in Ohio, but I wish it was then there. So I had a choice. Either I had to go to companies in West Coast, East Coast, and I was already established with my family. And so instead, I decided what NASA does. And I went into system. Again, another wave I picked up. Oh, sorry, did I do it? Okay. Another wave I picked up, and then I moved into NASA satellites area. So you can do that in large corporation and places like NASA to achieve that. So then new technologies came in 2000, space internet and lunar networking, and got involved in that. And then basically, I still wanted to keep going. Why? Another motivation, not only global satellite communication, the other motivation, Cleveland. A lot of young people, even in the state of Ohio, get trained in these high-tech areas, but we lag behind significantly over decade. It used to be innovation. Toledo, Cleveland, they used to be the most innovative cities in the United States, even when I came to Cleveland, but died out, and our young people move out. So that's the other passion, to keep the young people in our region. So those are the passion which are carried out. So what did I learn as an entrepreneur? I'd like to share that very quickly and pass it on to you. That catch a new wave at the right time. That's very critical. And watch the field and where the new wave is coming from, and how to make sure that simultaneously you're a very curious person and you're constantly learning. If you ask any entrepreneur, they will tell you that curiosity plays the biggest role. Just look at Bill Gates, Zuckerberg, and Steve Jobs, Elon Musk. Tremendous curiosity in them, and they take on new field, and they learn from all sources in the field. So continually monitor the environment, technically where things are moving, take calculated risk, but the practice, staying in the field and working with the best is a key also. And then keep an eye on the new development. So nothing new here, but I just want to tell you that that's how entrepreneur works. And never be afraid, never give up, and you learn from your failure continuously. So that's basically what I want to pass it on to you. But after that, I just want to show you one little thing, contribution that I did steadily to get involved in global communication. My first contribution was really to create a method for endpoint etching, which earned gold millions of dollars. And it was a very simple idea, because in physics and optics, you can measure thin films by shining a light, and then it's the thin film's thickness. You can measure that. But in case of semiconductors, people were basically looking in the chambers in the early days, and they had a very poor yield because they were just going by the color changes to decide when to stop the etching to create transistors on a small silicon wafer. So I asked myself a simple question. Hey, in the PhD, I was measuring thicknesses of very thin films on the semiconductor. Why cannot I reverse that process? I go the other direction. When the etching is taking place, the laser also start measuring, and then you know where to stop it. So that Google created a device from that and make a lot of money. And then I also worked in the integration and the packaging area for them. They moved me into management in a very short time because there was no talent. There's only finance people or simple mechanical engineers. So there was an opportunity, and I took that opportunity. So I began to build their, I think I was not even 30 yet, that I was building the plants for them in Japan, Europe, and spending a lot of time there in the printed circuit area, because this packaging techniques were then just emerging and automating them as well. So I then did semiconductor at the same time. So then the satellite evolution, I think I put this slide at a wrong location, but I only want to share with you is that same time, the satellites started in 1960, how things come together. And the Intelsat had a first early bird in 1965, and then it grew from there. And we'll talk about this growth, which electrical engineering, computer engineering enabled the growth. It's not mechanical aerospace. As a matter of fact, aerospace engineers are learning electrical computer at a much faster rate even than the electrical and computer engineers are doing that. So, but at NASA then, this was the most challenging activities I carried out. The miniaturization, believe it or not, our MMICs, work we did with all the aerospace, because again, public-private partnership. We were given $30 million in those dollars from the Congress, and the plan was simply to create for space gallium arsenide 3,5 compound semiconductor chips and the microwave devices. Very challenging. By the way, this is the work which then went into the phone you all carry. that entrepreneurs from this funded work and reducing all the risk of creating transmitters, receivers in a planar circuits and gallium arsenide, indium phosphide, because you needed power where silicon could not handle the power requirements in microwave circuits. I think many of them, you probably know that. And so this was a main development. I spent several years, but this took me to West Coast, and that's where all the manufacturing at that time was happening, not in Ohio. And so I was working with all the major companies in getting this product developed, and it went into phased array for the antennas as well. And then we got into superconductivity thin films, worked with many universities, was a great excitement how it can be used for microwaves. We created the first thin films with my partner, Joe Warner, who's still working with me in my company. So that's the collaborations and the networking, like here I am today. It's also key part of being entrepreneur, creating networking with professional people is a key to it too. So this is an example I want to give you. Our technology transfer, that's when I want to begin to understand entrepreneurship, that how companies were coming to Glenn Research Center and freely getting from civil servant work, all the technology, all the work, and the filter. Right now our work is used in wireless filters, cooled filters with the superconducting thin film. So there are several companies we aided on that. And then we created additional circuits from that, from nowhere. That's what I meant, what entrepreneur does. No laboratories, no tests, and you create totally new devices, new films. That was that kind of time. So low loss circuitry, which was used in hybrid hemp, we created for JPL. We worked on these devices which flew. So and then I got, because being interested in lasers always and optics, I got interested in I did something. Okay. So I got interested in the microwave optical control. This is a big area now, microwave optics, but we were just beginning in this area, and we did the very first work here also. So anyway, so that's just where the entrepreneurship comes in, that not to be afraid to take on new projects. Even at NASA, you have so you have to look at the environment, what I want to make sure environment. Some companies hire people, fire people. This type of entrepreneurship is very challenging. You cannot do that. You can even migrate to other companies. Only way you can do that, what happens in Silicon Valley right now, which is very difficult to do in our area. But in Silicon Valley, you can do that. But if you're in a large company, you can find the ways to become entrepreneur. But here's the thing. It depends when you graduate, how the field you will go into. Sometimes you have to take the job right away, but do you go in development? Do you go in testing? Do you go in manufacturing? Do you go in operation? And it pretty much will decide your journey. But even there, you can be in operation. But you know what I learned? The best challenges comes in while you're in the operation. But if you just stay in operation doing day to day, that's not it. But if you learn the problem solving in operation, go starting new things from that, you'll be surprised how your career can grow from there, working with the management. These are the kind of takeaway I'm trying to pass it on to you, that the choices you make after you graduate really will determine your course of your life cycle. So my passion about solving, Alexander Graham Bell, how he connected telephony, and then me in the global side, how can I make a difference? Because they were really getting to me. So many immigrants come to United States, and people move around globe, and satellite communications can play a huge role in global communications. So I took on that topic. Basically, I wasn't an aerospace engineer. I was coming from physics, electrical, those kind of background. But it's my fortune to pick that wave because our field was making remarkable progress. And you can see where we are today. And so the optical communications were developing with lasers and components, and that's the work we did there too. RF communication. The space internet was the most exciting part in NASA for me because simple reason. As a matter of fact, I want to share with you that Iridium is the first global network which was created in 2000, and it failed. With so much money was spent on Iridium, number of satellites, and they missed out the boat because what they had to do was to take the spectrum. Now 32-bit is for the telephony. They instead had to go to 16 or 8 because spectrum is extremely valuable, like a real estate in space. And in order to create thousands and thousands of connections globally, and so IP was coming in, and I was meeting with all these vice presidents. I tried to advise them, use IP. They didn't listen. They went to the old classical digital telephony, and they lost out on that. Because simple fact, what I had learned being in different countries, the time. If you think about making a phone call, you have to really, it's a limited time to talk to other country. Now, if you use text, or you're using what apps and everything, right? You get up in the morning, you see the messages, you are going flying like anything. So anyway, they missed it, but the other satellite companies really took it on, and that's where the growth happens. So you can see how these ideas take on. And the reason I got involved in this was very interesting. Again, public-private partnership. The internet was, at that time, with Cisco in 2000, with Bill Gates and Microsoft, and these companies have started an Internet Engineering Task Force. How many of you know IETF here? Just to check. Thank you. So it's remarkable what IETF achieves by collaboration globally. They don't create standards. They continuously move the field. RFCs, they're called RFC. And if you ever get the opportunity in the internet, in those areas, I think you'll enjoy that. They're the one who created all the things we are now enjoying that today, these days in space. But for me, the job was that the satellite companies started complaining that they're not including them, into the space, into the internet. And so they went to Vice President Gore, and I got a unique opportunity where we were selected to enable the satellite industry into space internet and how to do the standard in IETF. And so that went on a number of years, and so I learned a lot about networking. Of course, I was also able to work with academics and give them grants, and they carry out a lot of research to enable this area. And now satellite industry is really tremendously benefiting once the RFC in satellite got established. That was the hard part, to get the RFCs for satellites to go in there. And then this is the newest area happening in Earth science and deep space mission. Lunar communications have come in. So big development in these areas have taken place, and hopefully in future you will get an opportunity to come across this field. At Comstat, then, we are doing commercial satellite, working with commercial satellite networks now. We will talk about that. And NASA missions, small computers, all the technologies. Again, I'm just going over this for a simple reason, that it's really electrical computer software AI which is enabling the global communication. They build the structure, the design thing, but inside is all us. So, next one. Yes, please. So we also did experiments globally, which was my passion, and it was a rare thing to do, work with Japan and United States in connecting multiple satellites in those days for data motion. So we were the very first one to transfer videos across the globe. With advanced communication satellites was built at Galenica Center in 1996 to expand the bandwidth. The bandwidth was the key. So spectrum is a real estate, very expensive for wireless communication and as well as for satellite communication. So spectrum is everything. That's why optical is taking over slowly. So that happened, and then the space internet. This was exciting because of in the satellites, you had to create the processing, which took a lot of time. But we had to go from and the how many of you know even the model, internet model, OCI model? I, I thank you. I really, you're all electrical engineers? Maybe I want to make sure. Computer, electrical, software? Wow. Computer to computer communication. I teach that to Comstat because, you see, you're presenting the next generation where networking is taken for granted. Computers are taken for granted. So you just use them as a tool. In my days, they were not the tools. So, but it's very important to know how two computers talk to each other, which you use so ubiquitously, so quickly. So that's what basically it is. It's machine-to-machine communication. And the invention that changed the world, what you see today in your field, is how the stack, the OCI model was built to have an open network communication. Physical layers, data links layer, this is the old communications. You know, physical was just a telephony wire. Then we added modems and created the data link layer, and the IP is in the networks. And then came the transport layer. Now, that's something I want to pass it on, how problems are solved. So I remember OSU, all the major universities was getting NSF money, public-private partnership, to establish networking and routing and routers, all kind of things to create network data transfer across the United States before it became commercial. So when they were working on it, suddenly one day it stopped completely everywhere. Oh, what happened? So just analogy, what you will see in a highway, right? If the entrance and exit ramps don't have a control lights like in California and other places, you're going to get traffic jam, right? So they also experienced the traffic jam. So as a result of that, they invented the transport layer, and that's TCP/IP. TCP is what really controls all the machine-to-machine communication. Within a fractions of a second now, it happens. And your data can flow. If he's sending me the email from his computer to me, it can go all over the globe and come to me. But very minimum, because in TCP, it's basically finding the best route through routers to get the shortest distance to me. So I hope I passed something on to you. And please do look at OCI model. It's worth knowing in so many applications. In the future, you will see that. All right, so I'll pass on. I'll pass this on. I managed multiple technologies then, infusing them into NASA mission. It was very entrepreneur type thing. And then I began to do NASA Future Internet. It's our classic paper, how the internet will be used in satellites in around 2000 or so. We created that. First imaginative work on global and interplanetary communication. We produced that, and now these architectures are getting implemented in NASA. So NASA then brought me at headquarters to do the architecting and integrate all these advanced technologies. It was thousands of pages of work, system engineering documentation. Here, these are the visuals. So I like to pass this on to you because many of you are software engineers and PowerPoint charts and all that. So I found that in NASA, well-trained engineers, when you get them together on a problem, the egos in the room, they just talk to each other, and they can't. You'll experience that in the industry in many places. How do you solve that problem? So it was my big challenge to advance the NASA network, and engineers from different centers are coming in and have different point of views. So again, the technologies you guys are so familiar with, what you see here today, in my days, they were just coming in. The screens, very expensive, and how to project, and a PowerPoint chart. And every engineer wanted to do their own PowerPoint chart. So how do you get them all together? So what we started doing was I started hiring IT people to set up. Now it's automated system here, but in my case, IT people will set it up, the screens and everything, and I will create all the architecture diagram. And now the collaboration game changed. And that became a model in NASA. So all the engineers then start looking at the slides and not with each other, getting into, egotistical dialogue and no problem solving. So sometimes how tools, simple tools we develop, they solve big problems sometimes too. So that's how we got into these, to make accurate diagrams like they do in civil engineering. These are not cartoons. This takes a major effort in NASA even to know where their assets are in the space, because no one had this type of collective space communication diagrams and what connections are going on with station and moons and then different areas. So this is the future part of it. So I thought I'd share, why I want to share this part with you. If you go back in the history of engineering, very seriously, if you read those documents, you'll find out one thing, that the invention of engineering really took place with the very first sketches of the bridge in Europe. Sketch. And that's what I see lacking in my young engineers I bring in, because they're so much into computers. And so memory shortens out. So the first ideas, any first ideas, need to sketch them. The sketching and diagramming is a secret. When you look at a lot of entrepreneurs, others, how they produce ideas is not being talked about, and how it develops. So top engineers sketch things. They don't just think about it. They start doodling. So keep that in mind, that have a pad and just doodle. Even when I'm talking, start doodling, okay? It's a skill, and I guarantee you that skill will pay you off. Okay. So anyway, I thought I'd pass that on to you guys, that why it became very valuable for me. And of course, PowerPoint helps. So the last thing here to close the next chapter is that, great time is working, that I had a passion to pass on. I wasn't a professor, I didn't go into academic, but I wanted to pass on the passion of space and networking and all these areas. And again, I came across a very interesting situation. At NASA Glenn, mechanical, propulsion, even electrical, when we brought intern, so it's upon where you select your internships, if you get those opportunities. They have a great value. So they will bring them in, and they will work basically on test rig with a one engineer. Just a one equipment, one type of thing, collect the data, what you already do in the labs. So computers were coming in, and my senior people were complaining, and I'm sort of in the middle of it, and my own children were growing on computers, and they're complaining. And NASA went through it a lot, that these young people are spending all the time on the screen, and it's not a new problem, it's an old problem. And so I said, no. I know these young people have the one who take interest in these new technologies, they're going to revolutionize things. But I want to tell you, they're building things in software, and we need data from the diagrams. If you look at those space diagrams, well, before that, all the data was in papers. So I proposed to NASA that you need to create a data system and a web. So senior guy listened to me. He said, I can show you that these young people can do it in our area. You don't have to go to Harvard to have that data system built in. And we're talking about very early days of data. Now it's very common. So that is big strength in our company where I'm leading to. So I was able to bring significant amount of money, and I started the program first time, and now it's a big program in NASA for American citizens, actually, because that's the requirement in NASA. So I proved to them, this team here, the very first team, and now it's a huge program there every year, that we created a team group come in, gave them computers immediately, well networked, and they immediately, we created a NASA project-like process, and they created the first prototype, and the senior management came, could not believe what young people can do. And now they got it, and it became a futuristic thing that way. So yes, it's challenging the young people with the new tools, new activities, is where things can lead to. And always look for those opportunities, what I'm trying to share with you here, in different labs. So that's what, okay. So the last one is then founding the Comstat architect. So I will share one thing with you right away. It doesn't matter what age you think of becoming an entrepreneur, my God, you're really taking a huge risk. Thing is so different, so new. Doesn't matter you do it at age 15 or 20 or 30 or 40 or 60. It's absolutely nerve-wracking. There's no resources. You have ideas in your head, but that's it. And then how you translate them. I went through that whole process myself, but little by little we start building. And the first team took place in my own house, the first group, which is here, to strategize. But it was love of technology and satellites and mentoring the young people. And the other reason, I couldn't hire people in Cleveland who were experienced. So I'm saying, my God, I want to start this company. The experienced people are sitting in Washington, D.C. and California, and I'll show you some interesting chart that how difficult it is to start a company in high tech in our area. And we're trying to change that. I'm trying to use my influence with Congress and others, and it's happening, but it's slow. Because Ohio created innovation in the early days, and they went into big manufacturing, and now everybody wants to do manufacturing. So they don't take on the new technologies as readily in our state. So those challenges you're going to face too as an entrepreneur. So anyway, we grew from this small place to here. The other thing I did is that I actually firstly started with the wireless wearable. I did not know NASA will give us a huge amount of work, and suddenly we turned into NASA. But that's how it happens as an entrepreneur. You have to look at where the opportunities are coming from. Why, in my case, was that I didn't want to take any loans. I only wanted to invest my own resources, and nor did I want any other investors. So we created simply a cash flow company. That's the one type of startup that early on you create a cash flow. And we may move into the second cycle into investment, and that's something I'll discuss with you. So right now we are 35 to 36 now. We bring in 10 interns, 8 to 10 interns every year. We have every specialty now in our area. We need all these skills in satellite communication, and we will share with you all the projects we're doing here. And we create our early values in teamwork, responsiveness, growth, quality, creativity, and outreach, which is a very critical process to carry out. So 2014, training young people, and this is just another slide here. But this is very important. Many startup has an ideas, and they want to create a prototype, and then they look for the market and the customer, and the failure rate in startup is very, very high. I mean, 90 plus. Within 3 years, that much fails. Within 10 years, 1/3 fails. So I knew that, and it was very challenging as well. But one thing I had learned early on in my career, very early in my first job, and I like to pass that on. Doesn't matter which job you do, there's always a customer. And your immediate managers are not the customers. You try to please the managers, you're going to fail. I'm literally going to tell you this today. Until there is a manager who really cares for people. But not many managers do, especially when you go to large organizations. So you have to be very aware of that and the quality of your manager. Are they going to help you with your growth and promote you, or they only care for their own career and you're getting used? So that's something to keep in mind. So I always wanted to make sure who is really the customer, where the money is made, and how is it made. That's the only way you can circumvent this. Learn how the company makes money. And it's about money at the end of the day. So that's important. So the customer cycle, understanding customer needs, requirements, and then solution designs and implementation and testing and deployment. So it's a cycle of problem solving. And that's the other thing I noticed when I was bringing in interns in engineering, and I don't know, each school is very different, but one thing to keep in mind is that problem solving and how the problem solving cycle, very, very few universities in the United States teach you that. It's called design process. It's that simple. So integrate that in your learning processes, and it will have a high value to you. Okay. So last few slides and we're done. This is our major project, communication services project, and this is what's so exciting in our company is NASA wanted us because NASA had its own satellite networks in the geo orbit for station communications and spacecraft for Earth observation, weather. Basically, in our case, it's not ground-to-ground communication. In our case, it's bringing information which can sell and which is useful from space to Earth. It's a data, bringing the data down because of, and data business from space is leapfrogging right now. Especially climate change and intelligence and all those kind of things are happening. So the satellites orbits have changed from my days, and that's where the excitement is now with Elon Musk Starlink. We are working with 6 major companies, including Elon Musk company and Kuiper by Amazon. And so this was the best part at the end here, and Telesat, Inmarsat, and all the young people in our company are doing all the milestones, analysis, all aspects, and the interfacing is very challenging in the NASA spacecraft, or any spacecraft, because you cannot go fix it. It has to be highly reliable and work for many, many years, otherwise you're going to lose hundreds of millions of dollars. So it's a very different cycle of system engineering to keep in mind and how the data flows on that. And so we will go to the next one. Multiple applications of satellite communication in space, from launch vehicles to LEO ops, we call them, and terrestrial supports, low data rates, high data rates. It's a global business. So I'll pass this on. I pretty much talked that we are working on the NASA mission connectivity right now, spacecraft, and these orbits now. So our challenge is, this used to be one geo orbit, which is very stationary, and you can use 3 satellites to cover the globe communication, but there's a lot of delay, latency. And now with the MEO satellites at 1,000 kilometers, this is 22, and then 300 kilometers where Elon Musk and Bezos and many others, ESA, European, others are getting in China. And so that's the new thing, to basically have the cell tower in space, in this orbit. That's the new thing. So these are the 6 companies we are working with in every orbit, and huge challenges. And young people are contributing. We train them very rapidly in this area. So all IT. Oh, great, it works. So we create all these simulations, first time, very unique process. It's a very advanced software tools and techniques we interface, and how the NASA satellite will connect with the commercial network. It's about connectivity to commercial network. That's the new challenge for us. No longer NASA will build its own network. So that's what's happening here. Okay. And we are doing lunar communication also, which is also a high growth area right now, worldwide. And then we also do okay. So our architecture work is absolutely driven by data. So the software team we have 12 software engineers who build full stack, which is no web or simple thing, full stack for NASA on their servers, highly secure, and all their assets, all their mission, all the data, and then users can use the apps to utilize it. So that's a constantly income producing work for us now, because we made it operational. And we do the same thing with human research data as well. Okay, new passion. So the new passion now in our company is to take on the challenge of going into space. And we have designed a NEOSat, Northeast Ohio Satellite, for climate, because we are so behind in this that I want to see if our company can be the first one to get a commercial satellite in our region. And a lot of work is going on in our company in this area. The 3U CubeSat is all because of you, all your, from your field. A Stanford professor, I gave him my first grant from NASA, believe it or not, to create the students for electrical computing just in his thesis to get space internet in a small satellite. Basically, he was seeing how Apple was creating the phones and what was happening in the Silicon Valley, and he challenged his students to take a 10.5 centimeter, I don't know where it came from, 10.5 centimeter cube and bring everything microelectronics into this and the software and totally open up a new industry. And universities, many universities are doing this now. You can check that out in multiple places. And so this is our, in 2-3 years we plan to do this. And this is exciting work. Right now we're doing balloon experiments with Case Western Reserve University. And there's one coming to you now. This is the first one we did. And it's very, very, how to get the small computer, radios, software, connected to the ground, even to start out with, not easy. And University of Michigan, Ann Arbor, actually my student who I funded at Stanford became a professor, first electrical computer professor to join the aeronautics, Dr. Jimmy Cutler. And he does all of this now there, so we do work with him. You have to create a flat set, the whole design process on the ground, and this exciting work here. So that's where new companies are happening and worldwide. And now Africa and many other countries are getting involved, and they can have their own satellites, 12U, expand it out from there. So that's happening. But what I want to pass it on to you is, it's not the mechanical part, it's the brain. Spacecraft has highest requirement of a very smart brain. And for command and data handling subsystem, communication system, and the computers. That's what we are challenged right now. The rest we can is easily doable and available. Power is a big constraint. What we see with AI is our new challenge in the AI. I think you are probably familiar already with some of the things I'm talking about. We are too. So only last 6 months, we are moving in AI. A company from Ireland, because Cleveland is just our fortune in Cleveland now, that how connectivity happens, that you can go to Ireland direct flight now from Cleveland Air Lingus, and there are very large number of Irish Americans. So this is a part of American history, how Asians from India, China, and other Asian countries come to Silicon Valley and those areas. Europeans came on the east side, and Cleveland has the largest number of Irish Americans. And so as a result, they're building their connectivity with Ireland. This is a global thing happening because of internet connectivity and entrepreneurship. So keep that in mind, how you bring up these things together. So Ubartica is a CubeSat dimension. You can fit this board in a CubeSat now, and we're working with them in cloud detection and cloud mitigation. They have created the first fully useful board. This company came from Intel. Modius chip for AI. They created a small one. They got bought and made their first money, and now they're doing the space part. So we have a joint partnership, and we have their the chip I just showed you. I'm going to pass this on. Many of you probably are taking courses in this area. How I have few machine learning people. Oops, again I did that. Okay, so the AI models training with the cloud data sets is the key, and we are pretty much engaged in this. We just built a large laboratory to do this work because so takeaway, why we're interested in the AI in imaging area. Straightforward. Bandwidth is very restricted, and if you bring all the data down from the cameras and everything, is power hungry, and then you have to spend so much effort on the ground to sort out the data, right? If you want to see visible area and there's the cloud coverage gets thrown away, because we want to see where the openings are for intelligence and for many reasons, shipping and many things. We can talk about that application. So where the money comes from. So if you have AI image train in the spacecraft, then you only have to bring the data on the ground, what's really needed. And now you have to use less bandwidth, less power, except the AI chip, and that's where the challenge is in the power side. So that's the trade-off we're working on. So I think this will be of interest to you. And the imaging is the convolutional network we use for the imaging. And this is what Ubartica has achieved. All kind of data comes in, and then you get a real data on the other side. I just saw their demonstration at a conference. Many AI applications in space, and this is growing significantly in a commercial. This is everything I'm talking about is commercial growth, which even decades ago was not possible. So space has become commercial in every aspect. So that's a big change, and I'll share you some information here about that too, what's happening. AI in space, we see large-scale application, and we're trying to see which business area will be strongest for us. So in second area, why we have the joint agreement is because our background is how to take machine learning and apply it to communication. That was my relationship. I'm almost at the end. So that was my relationship with the University of Toledo a while back ago in cognitive communication and getting AI in space. There was a State of Ohio grant we had. So network routing, signal processing, these are very hard areas to utilize AI for space communication for electrical engineers. And edge and cloud computing, security. And so we are going to be working in this area and then transfer that to our partners. So, and a lot of research going on, but the application in the marketplace is very hard, and that's where we are trying to create. So last two slides I have is very much to do with how difficult it is to do business in our area. So where you do the entrepreneurship, you need tech talent. And tech talent is the most difficult part. And I understood that. I want to stay in Cleveland because my wife Charlotte still works there and want to stay in Cleveland, and I love Cleveland. So I took on a big challenge pretty late in my career to do that. And everybody I brought in, I trained them like any professor would, and then they train the next one and the next one. We cannot get this type of talent. Otherwise, we would have been a large company by now in the next 5 years, because you can ask me that question. And that's the challenge I face here. So sometimes you take on a difficult challenges when you're an entrepreneur. Okay, second one you see, when I started in 2014, why I had to create a cash flow company, because investments were not there. Now space is moving so fast in front of me from decades of work before in a public-private partnership, that all type of money has walked in. Now it may go down because space takes longer time, but tremendous investments are going on globally in the space startup companies only right now. So last slide here is that entrepreneur journey, you can study this on the internet, so much information. And every entrepreneur takes their own path. Some startup wants to scale up very rapidly, some get investor money. It's all type of journey. But in my case, I was happy. I was trying to put this together. Hey, to close in a summary, where I took this approach, and I found this on LinkedIn. I didn't have to create the slide. It's just exactly what I did. Firstly, define values. Took a lot of effort to define values with a passion. It's not about making money. Here it's not about making money. And then create product and services. We create services, and now we're going into product. Develop a business model. Yes, we have a modeling techniques in business, and they're available on the internet now. NSF and many other agencies put a lot of money for new entrepreneurs in high tech and business modeling technique. Start building infrastructure and execute relentlessly. This is the important part. It's 7 days a week, 70 hours. It's a nonstop. So thank you so much.
Thank you, Kul.